Hi, I'm Dr. Michael Shands. Wouldn't it be great if getting a new kidney was as easy as this? Well, you almost can, thanks to a new emerging technology called 3D bioprinting. So, how does it work? It works surprisingly similar to an inkjet printer, except in this case, instead of ink, it uses the patient's cells. Using the printer, it prints a layer at a time of the organ it's trying to create, and then a platform drops to add a third dimension. Now let's take a look at some real 3D printing. This printer is located at Wake Forest University, and they're printing a two-chambered heart, as you would find in a mouse. While it may not look like an actual heart, it would work the exact same way. Here they're taking the cells and putting it into the inkjet cartridges. From there they put the inkjet cartridge into the printer and start printing. The cartridge moves back and forth to put on a two-dimensional layer of the cell, while a platform drops to establish the third dimension. The printing process takes 45 minutes in this case, and the end result is a working two-chambered heart.
I am Iron Man.
Now let's go to Dan. We'll discuss the current state of 3D bioprinting, the future, and the benefits it can provide.
Recently, Organville, a company in San Diego, California, and Invitech, an engineering company in Australia, have developed a prototype 3D bioprinter that can produce simple tissue, muscle, or short stretches of blood vessels. Keith Murray, Organville's chief executive, is hopeful that in 5 years, the bioprinter will be able to produce blood vessels for use as grafts in bypass surgery. With more research, scientists at Organville are hopeful that their printers will create networks of blood vessels to produce larger printed organs such as kidneys, livers, and hearts. If this is possible, the next step in the process will be able to produce tissues and organs directly into the human body. 3D bioprinters have the ability to make organs as they are needed, so that patients who require these organs will not face any suffering or pain. With this technology, we will be able to save a lot more lives.
As you can see, the future is very bright for 3D bioprinting. Now let's go to Jen, who will discuss some more positive aspects of 3D bioprinting.
Another positive aspect that comes from 3D body printing is there is a lower level of rejection with the new organ. With 3D body printing, they use your blood cells and your DNA to make a duplicate organ. Whereas with a transplant, you're using somebody else's DNA, so there is an increased level of rejection possibility. Another advantage with 3D body printing is that people would have to wait for their organs a lot less than they would for if they were waiting on a list. People usually that wait on a list can wait years before they could receive any type of organ that they need for a transplant. By 3D body printing, the time would be cut shorter.
And now, look at the dark side of 3D bioprinting.
Even though that 3D bioprinters brought an enormous change in the medical field, especially for organ replacement, however, there are negative aspects related to this technology. First, 3D bioprinters are very expensive and can be harmful to patient health because they have side effects like blood clots, hemophilia, or even infected the area where the surgery has been performed. For example, if a surgeon is performing an open heart surgery and did not perform a good and careful job on the patient or arteries replacement, the side effect might be dangerous and even kill the patient later on. Also, concerning prototype performances, 3D bioprinters can be somehow very tricky to doctors because they cannot always replicate the organ with all its function, and it would be very dangerous for those who are performing the surgery on the patient, and it can kill them. That's the biggest problem. It can kill, or it can later on have some major problem on the patient's health.
Now let's go to Tom to discuss some of the current limitations of 3D bioprinting.
Experts say that 3D bioprinting could become mainstream in 20 years. The research necessary to make artificial organs safe for application to human patients is still in its infancy. While printed arteries could be used in bypass surgery in the next few years, and cartilage has proven simple to construct, creating organs and other body parts such as hearts, teeth, and bones via 3D bioprinting is more complicated. And while these body parts could be replicated in 10 years, there are risks to putting an artificial organ in a human body. An implant would need to be connected to blood vessels so that the new organ could be supplied with oxygen. In order to accomplish this, cultured donor cells would be used. However, even with this process, there is still the risk of rejection. Some may have moral qualms with this new technology, saying that a body is not meant to be anything artificial, and some other concerns that have been raised on this subject have to do with cost. These new artificial organs would be very expensive for a patient, and some feel that a large price should not be put on a life-saving technology such as this. Also, some feel that greater emphasis should be put on prevention in the medical field, and that a lot of money could be saved if these costly technologies were unnecessary.
So there you have it. 3D bioprinting is revolutionizing the medical industry. While it's very expensive at this time and has its limitations, further research and development will lead it to becoming more efficient and affordable and widely used. It's expected to save many lives in the future and is a great advancement in the medical field. We hope you enjoyed our presentation on 3D bioprinting.